Hello, welcome to lecture Storage Systems. So in this lecture, mainly I'm going to talk about different kind of storage systems, some conventional ones, also some are automated storage system. And lastly, I'm going to do a little bit of analysis of storage in production companies. All right, so the function of storage system is basically to store and also for retrieval of materials. Material can be the parts, can be work in process, or it can be finished goods. A storage system are usually used in factories, warehouses, distribution centers, wholesale dealerships, and also retail stores. It's actually widely used in many different applications. It is also a very important component in supply chain management. A lot of places use automation, and some places simply use non-automation. It really depends on the application and also the cost of budget for implementing automation. Some terms or some measures for storage systems. Sometimes you can see that one is storage capacity. So for storage capacity, mainly we'll talk about either the volume of the space or the number of storage compartments included in a space. Another one is a storage density. So storage density means it's a volumetric space available for storage relative to the total volumetric space in a facility, right? So basically, you have a shop or facility that how much material is how much space is available for storage, right? And also how much space is available in a whole space, whole facility. And accessibility mainly is talking about the capacity to access any item in the storage. Is it easy to to get the material, or is it a bit hard? You have to go around and then find different ways to climb different mountains to get the material. So that's accessibility. Also, one is systems throughput. Throughput means the hourly rate of storage and retrieval transactions. Right? Think about a library. Right? If you want to get material, get a book from a library, then someone will get it for you. But how many transactions you can have? Is it once an hour or multiple times an hour? Also, we can use utilization and also availability to describe storage system performances. Bulk storage mainly is talking about the storage in an open floor area. The problem with that is it's a little bit hard to achieving proper balance between storage density and also accessibility. Because if you pile everything all together, then it's just get a little bit hard to find or find the part or find the material you want. And it's sort of hard to access to it, but it has a high storage density because it's make every use of the space. Also, there's a rack system. So that rack system basically is a structure with racks, right, for pallet loads. It permits vertical stacking of materials, and some other system will be like the shelving and also bins, right? So and also a drawer storage. So these are some of the pictures. You can take a look at it. So this is the high density bulk storage. You can also divide it up and put into two rows, and in this case it increases accessibility, right, for the bulk storage. And another one is pallet rack system. So it places the pallets on the racks.
Pallet racking systems. Which one do I need? Most warehouses use a pallet racking system to maximize the storage space that they have, and because they come in an array of different styles, it can be difficult to decide which one is best for your business. Here's a breakdown to help you make the right choice. The most commonly used and easily installed system, selective racking, allows the pallets to be accessed from the structure's aisles. With beams providing a pallet support structure, it takes up the least amount of space and can be configured to almost any size needed. Then we have pallet flow. Pallet flow racking, also known as gravity flow, is all about moving inventory in and out faster. The loads are stored at the higher end and removed at the lower end point, employing the first in, first out loading system. It is very easy to manage and works well with clothing and perishable items. Then we have drive-in. The drive-in racking system is an affordable option that provides efficient space and storage capabilities. Often, this is used for like products that are non-time sensitive. This system is built with aisles in between, which allows for the forklifts to make their way through for constant stockings. There is also the pushback. Constructed in a structural or roll form, pushback racking is best for efficient storage while enabling inventory rotation. Using the last in, first out method, or FIFO, it helps to increase the visibility of products and allows for specific selection of inventory items. Then we also have carton flow. This system is most popular among warehouses that have a high volume of order picking. Carton flow racking, or span track, offers great storage for inventories that operate by first in, first out, or FIFO management. It uses a gravity feed, rear-loaded design, which helps in optimizing inventory management and operation. Cantilever racking consists of freestanding racks with front access, ideal for storing long and bulky products like timber, plastic piping, and steel rods. This system is often found in various settings like hardware stores, lumber yards, and plumbing supply warehouses. Are you looking to maximize your storage space? Visit.
All right, so that's pallet racking system, and also another traditional or conventional storage method is the shelving and the bins. We see this a lot. Also, we can see the drawer storage systems. So mainly, in this lecture, I want to focus on the automated storage systems. So automated storage, mainly we use mechanized and also automated storage equipment to reduce the human resource required to operate a storage facility. The cost is high, of course, but it really depends on application. Sometimes if you are using it to operate a really high frequency of transactions, or retrieval and also loading and depositing, then having automation will actually save human effort and also save a lot of money as well. And depending on the level of automation, it can be in mechanized systems, and we have operator to involve in it to for storage and also retrieval. Also in some of the system is fully automated, so which means all the loads and retrieval and depositing all under computer control with automation. And bunch of objectives why we are using automated storage systems. You can go through it. For example, to reduce the labor cost, increase productivity, to improve safety, and also to improve inventory control and the fast time to retrieval and storage, and increase throughput. All kinds of objectives we can achieve. So typically for automated storage system, it has a typical name. It's called Automated Storage and Retrieval System, ASRS, and there's a fixed ASRS system. So that's a rack system with mechanized automated machines to store and also retrieve loads. And also there's a carousel storage system, which is oval shape conveyor system that moves parts or baskets around. And so first, let's look at this ASRS system. All right, so basically this is the ASRS system. Well, within this general system, there are also multiple types. For example, we can load the whole pallet of materials. So that will be unit load ASRS, or we can only load some small loads. For example, some bins or drawers. Right? Let's look at this first, the pallet loads. So in this pallet loads, every time we load one unit, that will be the whole pallet. You can see there are gaps between different aisles. Also, there are some small loads, for example, some bins and drawers. All right, so also there are some of the SRR systems that with human operators. For example, it depends on the human to load and also unload of the materials or retrieve and store materials. Another type is automated item retrieval system. We can take a look at this. So this is a library
as an extension of the library shelf space, the ARS is recognized
store
for being
and
the most
retrieve
monumental
books.
computer-controlled location in the library. An automatic request for a book or video can be sent to the ARS with just a few clicks. The ARS stands strong for being one of the most efficient space-saving ways to store and retrieve materials such as books, journals, videos, and other materials that require lots of space. The crane moves to the bin and brings it to the workstation, where library staff locates the item and prepares it to be picked up at the circulation desk. The best part is that requests can be picked up within minutes. To see the ARS in action, visit the viewing room located on the northeast side of the second floor in the Learning Commons.
All right. And another one is vertical lift modules. So this is more for order retrieving, order picking.
Would you like to win back hundreds of square meters floor space in your warehouse? Then it's time to meet Alba. Alba vertical lifts can store your entire inventory in only 10 square meters.
So think about this
Access your inventory
system.
fast, efficient, and safely with vertical moving lift.
It can also be used in a lot of other applications. For example, parking cars, right? Maybe you can build this, car parking garage that it can automatically store your car and then retrieve the car for you. And then it is only using the vertical space instead of horizontal space. Actually, we can already see some of the car parking system are using this system in either in Europe, in Japan, or some other countries.
And best of all, you do not lose any space while inventory items with different heights are placed on shelves. That's called maximum storage on minimum space. One of the most important features of all of a vertical lift is its very fast order picking speed. While tens of pickers complete pick lists in manual picking approaches, only with few people, you can complete more orders faster, safer, and more accurately. You can reach 4,000 lines processed per day with a single person by removing time lost during walking corridors, climbing ladders, searching, or waiting for items. All the vertical lifts, flexible and robust software and hardware infrastructure makes it a breeze to integrate your already running system. Regenerative drivers we use on lifts acts as a power generator while descending. All this created energy is directed back to the system, which can be used anywhere else in your facility.
All right. So applications, it can be used in unit load storage and retrieval, order picking, as well as working process storages, as to support manufacturing functions. And another type of automated storage system is carousel storage systems, and it also can be categorized as horizontal or vertical. Let's first look at this horizontal one. So basically, this is how it operates, and you can either develop the system for order picking, or it can be some maybe self-selling supermarkets. Another one is the vertical carousel storage system. So in Santara Hospital, actually, I saw that they have this system, the vertical system, for picking some of the orders, and also picking some of the materials. Another type of course will be manual operated horizontal carousel storage system. So you can build this system, and then you just use human operator to load and unload material parts, and then you put it on the conveyor to transport to another place. And so carousel applications are typically used in order picking, kitting the parts for assembly, and also progress assembly and assembly stations located around the carousel system for with its transportation. And some analysis for ASRS. And first is the size. So how do we look at the size of it? It has three dimensions. One is x and y and z. So x. So basically, this is the x direction, right? It's the x direction, and also there's a y, which is this direction, and also the z direction, which is z direction, right? So now let's look at first W. For W, we can see, in order for us to find what is size, right? What the size it should be. There are different components. One is, of course, is the x. So x means which how much length of the load, right? How much length of the load for one compartment, right? For example, one compartment's dimension on the x-axis is this length, and then we're gonna add another a, which is Lawrence, right? Lawrence for in this axis. Then x plus a means that is the compartment, and also dimension, and also the Lawrence. Well, how long it should be for the x-axis actually is 3 times. Why is 3 times it? It's because we have one, right? One unit load, another unit load. Also, we have this, the L dimension, right? L dimension is also another. Usually we leave it another load for it. So that's 3 times of it, right? Of course, we need to add the allowance in it. Similarly, we can calculate, right? We can calculate how what is the dimension for the L, and also what is the dimension for the H. For the L, it should be Y. This is for one load, right? Plus allowance, and also times NY. NY means number of load compartments along the length of the aisle, right? Along the slide. How many? 1, 2, 3, 4, 5, 6, 7. Right? You can keep counting, right? How many of the compartments they have. Same with the H. We can count how many compartments on the H or the height dimension. And then of course this is use Z plus C. C is allowance for this direction. And then we use you can use 2 times NY times NZ. So NY means how many compartments in this direction, and NZ means how many compartments at this direction. Now we can calculate actually how many compartments for one side of the aisle, right? For one side of the aisle. Well, because we have 2 sides, we need to time 2 for it. So this is how we calculate the total compartments or the capacity per aisle of the ASRS system. All right, now we can take a look at this example to demonstrate how do we use these equations. So each aisle of a 4 aisle ASRS system. Now we are looking at the 4 aisle ASRS system. Now it is talking about each aisle. Each aisle contains 60 storage compartments. Right? I already mentioned to us. It's a total compartments is 60 in the length of direction and the 12 compartments vertically, right? Length direction and 12 compartments vertically, and all storage compartments are the same size to accommodate standard size pallets of dimensions. You have X, have a Y, and also we have a Z. Now using the Lawrences of A, B, and C. Now we need to add an A here. A is 150 millimeters, 2B is 200 millimeters, and C is 250 millimeters. Now determine how many unit loads can we stored in the ASRS system, and also the width, the length, the height of the ASRS system. Right. So first, if you want to look at ASRS capacity, so basically we need to, if we want to calculate one capacity, we use 2 times the how many compartments at the length, right? The L. How many? Well, we have is 60, and how many at the height, right? The height, which is 12. Right? So this is how we get the total compartments in 1 L. Because we have 4 L's, so we times 4, right? Times 4 L's. This way we can calculate the total compartments actually 5760. Right? This is the total capacity. And then if you want to calculate the width, length, and also height of those, we have the equation that width will be 3. Remember, we have 2. Each aisle has 2 sides, and also there's a middle empty space we need to leave, right? So the 3 times what? Times 1,000, which is X, right? X 1,000 plus A with the Lawrence, in this direction, so 150. This is all in the millimeters, right? So we get this equation, we calculate, we got 450 millimeters, which is around 3.45 meters per aisle, right? Then similarly, we can calculate L, which is we use 60 because why? Because we have 60 storage compartments in the length direction, right? Times how many? What is the dimension for the Y? It's 1,200 plus B, right? B 200. Then we get it's actually 84 meters, right? Then the H will be 12 because about 12 compartments times 900 Z plus C, right? Plus 250 millimeters. Then after all the calculation and we convert it to meters, we get 13.8 meters. So this is how we calculate the required size of the ASRS system. So you can see the solutions here as well. And all right, next one is we want to calculate the throughput. So calculating throughput is a little bit complicated because it depends on the command. So sometimes you have only one command, which is to just to go and pick up one thing from a position, and then you come back. Well, sometimes you might have multiple or dual command cycles. For example, you get 2 commands, which is now go to one position to pick up item 1, and then go to another position to pick item 2, and then come back. Right? So this is a dual command cycle. Well, if you want to calculate the throughput, typically we need to include both the single command and also dual command. Of course, sometimes there can be multiple commands. In this case, the calculation will be a little bit more complicated, but generally we're going to look at, in this lecture, mainly we're going to look at one single command and also dual command. Well, first let's look at for one cycle. Okay, how much time is actually required to finish one cycle. So finish one cycle will include the load, right, which is a deposit, and also the pickup time. So deposit time will be, it include the time spent here and also time spent here, right? So at two places, one at the beginning and one at the end. So that's why we need to use 2 times the time, right? So this is y times 2. Well, another part is which is transportation time. All right, how do I move the automated device or tool, from this space from this position to this position, all right? So moving here, actually, it's a linear direction, or it's a linear movement. Well, how do we get the time? Because of linear movement, with this direction. So this direction actually includes 2 velocities. One is the velocity go up, and another one is the velocity going to this direction, right? Well, then how much time does it take? How much does it take? It really depends on is this h is longer or is this l is longer. For example, if the point is here, then in this case, right? In this case, l will be longer, right? L will be longer. Well, if this point is here, in this case, h will be longer, right? So this is why we're going to use the max to calculate how much time it takes, with the different points. So we're going to look at, 0.5 L divided by Vy. So 0.5 L divided by, why do we use 0.5 L? It's because in average, right? In average, we're going to look at the point, at the, right in the middle of the whole rack, right? So this is 0.5, and also same with 0.5 times h. That's for the height. And also we got velocity. So we use this to divide it by the velocity, and then calculate the time spent this direction and also time spent this direction. And look at which one is bigger, right? Then I'm going to use the bigger time as our transportation time for to arrive that destination. And also, of course, you need times 2 because there's a go and a come back, right? Times 2 go and come back. And then this is the equation we need to calculate, right? And further, we can actually put the 2 inside. Then we got L divided by Vy and H divided by Vz plus 2 times T pickup and the deposit time. So this is the equation to calculate the cycle time of single command cycles. All right, so how do we calculate the cycle time of dual command cycles? Well, for the dual command cycles, we know that there are 2 times a pickup and deposit, right? 2 times pickup and deposit means we need to times another 2, right? Times another 2 based on this, right? Based on this, right? So that's why we need to have about 4 times the TPD, because each one TPD is only one action, right? 2 will be 4 actions. And also because we have two commands. After a part moves the once, for example, after the part move at here to here, then there's another action, which is there's another position, a point. In this case, in average, we're gonna put that point here, and then to calculate the space or the length, from this point to this point. Yeah, remember, this is by average, right? Average. It can be this point, it can be this point, or it can be this point, it can be this point, or it can be this point. But in average, this is the point we're going to look at. All right, so how can we calculate the times for transportation? Well, if the point is here now because of the two command cycles, then let's look at L. So L will be half of the total L divided by plus a quarter of the L, right? A quarter of the L. Same with the height. That will be half of the h and also a quarter of the h, right? So this is the length of this of two different directions. Well, the cycle time then will be look at which time is longer. It's similar as the single command cycle. So you find the time here, this direction, and find time at the other direction, then times 2, and then we reorganize the equation, and we get this equation. Right, 1.5 L divided by Vy, 1.5 H divided by Vz, find the maximum number of it, plus 4 times the pickup and the deposit time. All right, so that's about the calculating the cycle time of a single command and also a dual command cycle. Then I'll look at what about the frequency? So frequency will mean the number of single command cycles performed per hour, and also number of dual command cycles performed per hour. Right? We need to know how many transactions, right, or how many commands I need to give in order to find out what is transportation of those. All right, so then we use RCS, which is single command frequency times the cycle time, right? So this is how much time I actually used during 1 hour for the single command. Well, this part will be how many time I actually totally used during 1 hour for the dual commands. And then we can calculate, right? Equals to 60 that's minutes, right? Well, in 1 hour, how many minutes? And U will be the utilization rate, right? We can use this to calculate what is the utilization rate, right? And then the total number of transactions, of course, is to be the RCS plus 2 times TR CD. Why is 2 times CD? Because for each dual command, right, cycle, there are 2 transactions, right? For each dual command cycle, there are 2 transactions. That's why we need to times 2. All right, so this is the equation for calculating the throughput, total transactions, and also the utilization. Now let's look at another example. So the example is consider ASRS system from prior example in which SR machine is used for each aisle. So the length of the storage aisle is 84 meters and its height is so this is the length and this is the height, right? So length is say 84, it's 13.8. Suppose horizontal and the vertical speeds of the SR machine are 70 meters per minute and 25 meters per minute, respectively. And SR machine requires 20 minutes to accomplish the pickup and deposit operation. So now we get this variable. Determine the single command and the dual command cycle times per aisle, and then also the throughput per aisle. And first, let's look at the cycle time for the single command. So single command, we know that we can calculate by the TC single command equals to what? Remember, there's a max of the time, right, at each of a direction. First one is this direction, 84. Then we divide it by the speed for this, which is 70, right? 70 here. And also another direction is this direction, which is 13.8. 13.8 divided by the speed of that direction, which is 25. All right. and then plus 2 times what? Times T, what is the equation over here? 2 times TPD, right? 2 times TPD, which is 20 seconds. Remember, this is 20 seconds to accomplish. If you want to convert it to to minutes, because this is the minute and this is the minute. So we have to convert it to minutes. That is 60, right? So here we can find out that this value is actually 1.867 minutes per cycle, right? And similarly, we can calculate the dual command, right? The TCD dual command equals to the max, right? Remember that is a 1.75, 1.5, sorry, 1.5, right? 1.5, right? Times 84 divided by 70, and 1.5 times 13.8 divided by 25, and plus 4 times 20 divided by 60. Now we calculate, we can get the number should be 3.133 minute per cycle. All right, so this is how we calculate the cycle time for single command and also dual command. And then next we're going to calculate, okay, what is the throughput per IO? And an assumption that the storage system utilization is 90% and the number of single command and dual command cycles are equal, right? Are equal. So the throughput will be what? Will be, okay, so how many transactions, right? How many transactions per hour? How many transactions per hour equals to what? Remember, total transaction equals to RCS, which is a single command, right? Single command plus dual command. 2 times RCD. Dual command. Okay. All right. So if you want to find this, then because we know single command equals to dual command, now we just need to find out, okay, how can we find either one? How can we find either one? As we find one of those, we can calculate how many, what is the total transactions per hour, right? Now let's look at what kind of other condition do we have. We know that the storage system utilization is 90%. So which means we know the utilization, right? We know the utilization. So which means how much time per hour during 1 hour is actually used for all the transactions, right? So in this case, we can use the equation of which equation? This equation, right? This equation to calculate what is the total time spent during 1 hour for conducting both single command and dual command transactions. So RCS times the cycle time, right? Cycle time for single command, which is this number, 1.867, plus dual command, RCD times 3.133, right? We have got this equation. Number of dual commands, right? And equals to what? Equals to the total time, which is 60 minutes times utilization rate, right? What is utilization? It's 90%, which is what? Which is 54 minutes. 54 minutes. And because we know RCS equals to RCD, right? We know that RCS equals to RCD, so we can find that actually this number equals to 10.8, right? Put this in equation, we can find 10.8 cycles per hour, right? 10.8 cycles per hour. Or 10.8 transactions per hour. It's the same. And then the RT, right? RT equals to RCS plus 2 times RCD right? The 10.8 plus 2 times, right, 10.8. And we can find out it's actually 32.4 cycles per hour, right? Or transactions per hour. So this is how we calculate the total throughput for this ASRS system. All right, it's not finished yet, because it's the 4IL, right? 4IL. So we, for 4IL, then we just use 4 times RT, and we get 129.6 cycles per hour, right? Cycles per hour. So this is how we calculate the total throughput for this ASRS system. All right, so for this lecture, we talk a little bit about the automation that used in storage. We look at some of the equipment, and also the systems, and also the machines that have been used in production. Those storage systems are actually not just in production manufacturing, but also in a lot of other applications, like medical, in supermarkets, or car parking, in any places that need storage. All right, that's all for today.